Okay, I'm going to show the answers to the Quiz 7 previews, sections 5.4 to 5.7. Number 1 should be 9i. The square root of a negative will have an I value. 2, 8i, x to the fourth, y to the third times the square root of y. Number 3, you can simply drop the parentheses because it's addition, and then combine your like terms. So you get negative 3 minus 4i. Standard form is a plus bi form. Number 4, you need to distribute the minus sign when you subtract, so be careful. You should have negative 7 plus 16i, because that is negative minus 12 plus 3i. On number 5, you're multiplying twice by into this, you're distributing twice, I like to say, instead of FOIL. 2 times 4 minus 7i would be 8 minus 14i. Then multiply by 3i. That'll be an additional 12i minus 21i squared. You need to have memorized that I is the square root of negative 1, that I squared is negative 1, that I to the third is negative I, and that I to the fourth is 1. So you combine, first you combine any like terms here, that would be minus 2i, but I need to replace the I squared with a negative 1. That will give me 8 plus 2, so that's going to be 10 minus 2i. Number 6, there's an I to the fourth times an I to the third. Did I do something wrong? What did I do? Oh my gosh, that's a... Hello. I have got to fix that. I thought it seemed odd to me that it didn't seem like the answer I got earlier today. I all of a sudden decided to make the 7 a 2 somehow. Is that what I did? Okay, so that'd be 8 minus 14i. I think I started that right, and then it was here that I made a goof up. That'd be plus 12i, and then minus 21i squared. Thank you very much for showing me that. This would be 8, still minus 2i. I had that part right. But then I have to replace the I squared with a negative 1. So it's going to be 8 plus 21. Now I know what happened. And that's 8 plus 20 is 29. Oh, no. Yep, that is positive. Okay. So 29 minus 2i, is that better? Okay, sorry about that. Now, 6, I just started up here. I broke apart I to the 7th into I to the 4th times I to the 3rd. And that leaves me with 1 times I to the 3rd, and I to the 3rd is negative I. So the answer to this question is negative I. Okay, number 7. We need to multiply by the conjugate of the denominator because we need to get I out of the denominator. The conjugate of 1 minus 3i is 1 plus 3i. And you got to do what you do to the bottom to the top. Okay, so I've got some writing to do. I multiply 5 times the two terms. I get 5 plus 15i. I multiply I times the two terms in the second parentheses to get plus 1i. And I times 3i would be plus 3i squared. All right, in the denominator, 1 times 1 is 1 plus 3i, and then minus 3i minus 9i squared. Now, the reason I multiplied by the conjugate was the i's will wipe out. These terms are opposite. I replace any I squareds with a negative 1 and combine any like terms. So right now I've got in the numerator 5 plus 16i. Then that's going to be plus 3 times negative 1. And I'm writing out the steps for those who haven't practiced enough to know this well and need to learn it. 1 minus 9 times negative 1 is in the denominator. I will evaluate 3 times -1 is -3. 5 plus -3 would be 2. So I got 2 plus 16i all over 10. Okay, now knowing that all three numbers out here are divisible by a common factor of 2, I can reduce. 2 divided by 2 is 1. 16i divided by 2 would be 8i, and then there'd be a 5 on the bottom, and that's the answer. Okay. That is actually not in A plus BI form yet. I have one more thing to write. What would A plus BI form be? Okay, 1/5 plus 8/5 times I. Okay, good. Heard several of you saying that. Okay, number 8, solve. How would you solve this? What method would you choose to solve? We've done several methods. We've actually done quadratic formula. We've done solving by graphing. We've done the square root method. We've done completing the square. You have to know all of them. What's the best, easiest one to use on this problem? Square root method. Yeah, why? Because you can quick subtract 5. Okay. That's what I would do. It didn't say what method. That's why I asked that question. Okay. And then I would divide by 2. And then I would take the square root. But don't forget, how many solutions? Yep, plus or minus the square root of -32. Now, simplifying that, 32 -16 times 2, so I'm going to have plus or minus 4i times the square root of 2. And that has to be in that order. You can't have 4i in front of the plus or minus. That changes everything dramatically. Looks like the square root method would work on this one too. If you divide by -3, what do you get? -45. Then we take the square root of both sides, positive or negative, square root of -45. We break down the 45 into -9 times 5. So that's plus or minus 3i times the square root of 5. And now I'm going to subtract 1, and that goes in front. Subtract 1, -1 plus or minus 3i times the square root of 5. Okay, anybody still need this? All right, number 10, use completing the square to find the center and radius of the circle. Center and radius form is x minus h quantity squared plus y minus k quantity squared equals r squared, where hk is the center and the square root of r squared is the radius. So I'm going to rearrange my x terms together. I'm going to put in a blank. Going to rearrange my y terms together, put in a blank. And then I'm going to subtract 23 and put in a couple blanks over there, because I got to complete the square twice. You take half of the coefficient of b, if you will, the value of the coefficient of the x term, not the x squared, and I square it. So the 4 squared goes in both of those blanks, which is, of course, 16. And then I factor this, x minus 4 quantity squared plus y minus 4 quantity squared equals 9. -23 plus 32 is 9. Next, I say, okay, the center then is 4, 4. If I could get my pen to go to the blanks, having its own mind. Come on. Okay, 4. Oh, What is happening? My goodness, that was strange. 4, 4, and the radius would be the square root of 9, which is 3. Okay. Okay. X squared minus 6x plus blank plus y squared minus 2y plus blank equals 6 plus blank plus blank. Oh, sorry, it's negative 6. I wasn't moving it. Or adding or whatever, excuse me. Negative 6 plus blank plus blank. Half of 6 is 3. Squared goes in the blank, or 9. Half of 2 is 1. 1 squared goes in that blank, which is 1. Factor it. And then simplify the right. Negative 6 plus 9 is 3, and 3 plus 1 is 4. So now I see the center is 3, 1. Yep. And square root of 4 is 2 for my radius. Is everybody good? Or does anybody still need this page? Okay, solve by completing the square. It's telling us the method you have to use. So that is the only method you can show. You must show the work. If you just have an answer tomorrow on the quiz, you will have the problem marked wrong. You have to show that you did completing the square. Another method is not going to cut it. So I hope that's clear, guys. You got to do the method if it's specified. Okay. Add half of 10, 5 squared to both sides. Then this is factorable as x plus 5 quantity squared equals 27. You next take the square root of both sides and get plus or minus the square root of 27. That will simplify to 9 times 3, so it's going to be subtract 5, negative 5, plus or minus 3 times the square root of 3. Okay. This is to be done by completing the square. Here's another one where if you don't show that you did the work by completing the square and all you give me is the vertex and you have the equation, it will get marked wrong. Okay, I'm warning you. And that's because you have to show it by completing the square. There are other ways for you to get this answer and fake it. Okay, so you got to show the work. All right, so x squared plus 8x plus blank plus 13. Now, if I'm doing it all on one side, if I add something, how do I balance that? Okay, subtract it. Okay, make sure you study this. This is too easy to not get correct, but too easy to forget and then get it marked wrong. Okay, by not practicing. Okay, half of 8 is 4. 4 squared goes in the blank, which is 16. Factor that to x plus 4 quantity squared and then simplify minus 3. There goes the problem. You've got your vertex. This is the equation that goes here. Okay, and then the vertex is negative 4, negative 3. Okay, remember we were trying to get it into y equals a times x minus h quantity squared plus k form, which is vertex form. Okay, what does this mean? Find the zeros. Okay, say that louder, Josh. X-intercepts, yes. Okay, x-intercepts or zeros or solutions or, well, x-intercepts I like the best because it makes you think it crosses the x-axis there, I hope. But the zeros, the x-intercepts, the solutions, the roots, those mean all the same thing. So when you want to find the zeros, that's when f of x is 0, the y part. So we set it to 0 and solve it. Well, I would do factoring on this one, and I would say, hey, there's something in common to 3x squared and 9x. They both are divisible by 3x. And then I say, okay, 3x squared divided by 3x is x, and 9x divided by 3x would be 3. And now that I have factors, you set each factor to 0, solve it, you get 0 for one solution, and set the other factor to 0 and solve it, and you get -3. Okay, other side. Where's 14? That was 14. Sorry. Okay. Use quadratic formula. The method has been specified. You must use it, despite the fact that this is easier to do by factoring. Opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2a. You better have memorized it. You will not get it on the test. No, you will not. And you will be using my calculators in case you have it stored. Oh, yeah. Okay. And you better not put it in that calculator because I'll know what class did it. All right. Then besides, you have to show the work, and it has to be in simplified radical form. All right, ready, set? Let's say a is a 1, b is -12, c is 20. You don't have to write those down, but you may if you wish to. The opposite of b would be 12, plus or minus the square root of. B squared would be 144. Don't forget, this number will always be positive, okay? You're squaring it, no matter what sign it is, it's going to be positive. Don't make that boo-boo of using the calculator and then it turns out negative because of how you typed it. -4 times a is 1 times c is 20, all over 2 times a, which would be 2 times 1. That gives us 12 plus or minus the square root of 144 minus 80, which is 64. I do not know why I have a ginormous square root symbol. I shrink that down a bit. And then on the bottom, we just got 2. Then you can simplify the square root of 64 to 8. And now let's find those two answers. 12 plus 8 is 20. Yes? Did I do something? No, I would do it last. Just because well, you could, yeah, you would. If you did it correctly, yeah, because it would be 6 plus or minus 4, which would give you 10 and 2. That works. Yeah, that does work. Just be careful and make sure you did all 3, right? All right. And 12 minus 8 would be 4 divided by 2, which is 2. Okay, so you got x is 10 and 2. Okay, and the next one, a is 3, b is 6, sorry, c is -1. The opposite of b, -6 plus or minus the square root of. B squared would be 36 minus 4 times a times c, all over 2 times a. Yes. Dan. I'm sorry, was it on this problem? Like how I got here? Oh, got it. It would be, yep. You're fine then? All right. No, I want you to know where it came from. So, -6 plus or minus 36. This is going to be plus 4. Right? No, plus 12. So that's going to be the square root of 48 all over 6. Now, 48 divides into 16 times 3, or divides into the product of 16 and 3, perfect square, non-perfect square, is 48. The square root of 48 is 4 of square root of 16. I'm sorry, I got distracted because somebody dropped something. It's not, I'm not mad. I just wanted the people to know I said something wrong. Anyway, doesn't matter. Divisible. We got divisibility for all 3 numbers outside of the radical. Therefore, what can we divide them all by? Okay, so this final answer is negative, my pen stopped, 3 plus or minus 2 root 3 all over 3. And maybe I should write that somewhere else so you can be sure to see it. That's what it looks like. Isn't that special? Yes, Haley. You still couldn't, because remember, like, people in jail can't hang out with people outside of jail okay? So don't do that. If you have radical over a radical, though, so if you had something like that, now you can divide those, okay? Alrighty, describe a quadratic function graph that has one real solution. What's that do? Somebody's on the right track. So maybe you started off with a perfect square trinomial, is what I was thinking I heard. What does that mean? Okay, okay. So what would this particular graph look like if it has only one point? And what point is that point? Yep, it's a parabola whose vertex is on the x-axis. It's a bounce, yep. Good, I'm glad. I was looking for that word too, and nobody said it yet. This vertex is on x-axis, bounces, because it has a double root. Okay, and if you just told me its vertex is on the x-axis, okay, it intersects the x-axis one time, and it doesn't go through it, it bounces off of it. All right, if it has 2 real solutions, it's a parabola that does what? Okay, that crosses the x, or intersects the x-axis twice. Okay, if you say crosses, that's okay with me. And ones that have 2 imaginary solutions would be parabolas that doesn't cross the x-axis, doesn't intersect the x-axis with no x-intercepts. That does not cross the x-axis. Okay, so, you know, and if you feel like drawing yourself a picture of what these look like, you know, an example. It's up to you. But I'm expecting, when I ask this question, a word answer, not a picture, okay? And a picture would be marked wrong, or at least you wouldn't be given very much credit. You have to say it in words, okay? 2 imaginaries, I'm just showing that you can have parabolas that do these kind of things. I don't know why I put them all on the right side of the y-axis. I just did. Probably because I'm fitting them. Okay, factor this polynomial completely. All right, you got 4 terms. What are you going to do? That starts with a G. Group them. All right, grouping. Factor by grouping. Not grouper. 5x squared is factorable out of those 2 terms. I get x minus 7. And then I factor out a 3 from the second 2. I get x minus 7. Since they have x minus 7 in common, we factor that out. And what would be left is 5x squared plus 3. Okay? Then you can't do it. Or you did something incorrect. That's one or 2 options. Okay? If they aren't matching, if there's nothing matching here, double check your work. Make sure you took enough out or something. And then if it still doesn't happen, then you can't factor it by grouping. There are some things like that, but I'm not probably going to throw one on your quiz. All right, solve each by factoring. So we got to bring everything to one side, if you will. Okay, and this is a perfect square trinomial. So it has one solution. So this graph of this parabola, guys, would do what? It would bounce. All right, and this one goes x plus 4 times x plus 1. Can you just give me a minute so we can finish this, or no? I mean, you can look it up on the recording if you wish, but. Okay, x plus 1 equals 0. You get x equals negative 1. You guys know how I got negative 4, right? I set it to 0. All right. Okay. 21, what's the vertex of this? Would be negative 3, negative 1. What is the equation of the axis of symmetry of the parabola? Well, so wait a minute. What about the opposite of b over 2a? Isn't that how we found the vertexes? But why am I not going to use this? Very nice. Okay, it's in vertex form. And so since this is in a vertex form, you can see that the x value of the vertex is negative 4. Therefore, the axis of symmetry is x equals negative 4 because you remembered it's x equals 8. And use this equation for objects with the rate in meters per second. All right, here we go. Last question on the quiz preview. Thor, sounds like a Marvel movie. Thor threw a water balloon upward from an initial height of 8 meters. That would be your h sub 0. Initial velocity of 10 meters a second. Ouch. Funny bone. Ouch. All right, so the height of this balloon, negative 4.9 because it's in meters, times t squared, plus initial velocity 10t, plus the initial height of 8. Someone had a long arm. What is the height of the balloon after 2 seconds? You can plug that in. All right, and then you calculate away, and that comes out to 8.4, I believe, meters. I think I have it. I have the answers. I've done this already. I know you guys can type on a calculator, so there we go, 8.4 meters. And now, how long did it take for the balloon to reach the ground? You're going to want to go into your grapher, put the equation into y1. All right, and then you're going to see something probably like this. All right, and you're going to want to find when the height reached 0. So basically, you're putting in 0 into the equation so that you can put it in your grapher. Okay, but anyway, I can't solve that without the grapher. My calculator doesn't want to work because my computer is really slow, but I'll try again. Yeah, I already see something on there. Okay, what did I do last time? I think I reset it. Yep, that works. Did you guys find it already? All right, you got 2.666. Is it rounded properly? Okay, I don't need to go over that. All righty then. I will just do it because I need. Oh, okay. That's the quadratic one, huh?
Page 97. I finished.
Why, in class. And when did you get this quiz preview done then?
Yeah.
Okay. Wait, what was that, Scott? Now say it again, please. Okay. Have a nice evening. We hit second. Trace, in case anybody's still interested. Choice 2 is the 0. It's between, and I'm doing a left bound, a 1. Did you need me? And a right bound, a 5. There's some back there, I think, on the cart. Hit enter again. And that'll pop you onto it. There we go. 2.66 seconds.